I started off the design process by doing a ball and socket design. This will be for the suspension in the future, but it just gave me a good idea of tolerancing for the 3D printers and a lot of other basic skills. Here's the axle. It is a pulley-driven axle. It will be a four-wheel drive vehicle, and so the pulley will turn the axle, which in turn turns the wheels. Here's the track tire design. It'll be developed in the future. It uses bearings and has a lot of rotation and has increased surface area with the obstacle course. Here's the full assembly together. Front and rear, there will be four-wheel steering. There's the steering linkage, which allows both track tires to rotate, and then again the axle. Here I used a Prusa 3D printer. Getting tolerances and printing correctly was a struggle at times, so there were a lot of failures, but I eventually succeeded in printing a prototype of the track tire. The track is currently not developed fully.
So for our app, we used a Python add-on called Kivy, and so it creates a widget for us to run it off of. We used Wi-Fi because we could not get our Bluetooth to work. We used Python sockets, and so basically what we do is we have a bunch of widgets, and before the app actually will not run unless connected to this. And so the code here we have just start server, and so it binds to a IP and port, and then we initialize our motors, initialize our servo right there, and then we connect. It'll time out if it does not connect in time, and once it's connected, then we will open up to receive messages from the app, and then it'll decode the message, and then now we have our if statements, which go from if move, which is basically because we're sending strings from the app to the car, and these are the words that are sent in the string depending on what we're telling the car to do. And so we have if statements that will take and interpret that string, take the digit out of it, and then convert the digit to an actual integer. And then we have motorall.reverse with value int, which will take that value and go in reverse. And we did the same for everything, and then we just have like a placeholder for ramp right now, because that is how we're going to hopefully deploy it to get over the wall. And so to see what the app looks like, we start the car, start our app, and it looks like this. We just send ramp, ramp command received, and we have the settings. It's not really done yet, and then move the car.
So at the project network, we have the nodes listed on the right in order to have a better illustration for the project network. We start with the tunnel. From the tunnel, we move to it's just a little bridge. From there, we move to trails to rails, then to the hill climb, which is a very hard obstacle. From there, we go to the first one's a doozy, and then the desired path for the rest would be barging through to rough and tumble, and then to the final obstacle, which is the rock field. There are still analysis to be done and more testing to be done in order to find the best path, the optimal path, in order to reach our goals.